everyone. Today we are going to be working on our subtraction. With our subtraction, we are going to be working with multiple digit numbers. And when we are working with these multiple digit numbers, we are going to be using an algorithm that is a standard form. And so we will work on this throughout the video, and hopefully by the end of it, you have a good understanding of how to subtract using this standard algorithm. We are going to be using the chip abacus today, and we're going to go over the values. So one chip is equal to 1. If we have 10 ones, this is equal to 110. And if we have 10 tens, this is equal to 100. And we can go back down to exchange the 100 for 10 tens, exchange the 10 tens for more ones. We are going to represent a number first to practice our representation skills. So we're going to do 352. So 1, 2, 2, 3, 4, 5. So 352. We have 3 100s, 5 10s, and 2 1s. So for our first problem, we are going to do 392 minus 57. And this is what it would look like on your paper. See how I lined up the place values? So we have the 1s, the 10s, and the 100. I am going to set up 392 on my screen. You could pause the video and set it up on yours as well. So as you see on my screen, I have 392 set up. I have 3 100s, 9 10s, and 2 1s. So for our first problem, we are subtracting 57. Let's focus on the 1s. So 2 minus 7. We don't have enough 1s, so we are going to have to regroup. And regrouping is important to be able to make new numbers and subtract when we don't have enough. So we're going to take 110 and we're going to exchange it. So get these organized. And now we need to write this down on our paper, what we just did. So we took 110 and exchanged it for 10 1s. So how many 10s do we have left? 1, 2, 3, 4, 5, 6, 7, 8. So we are going to cross out the 9 on our paper, write an 8 above, like that. And since we added a 10 to the 12, we're going to write a 1 in front of it, like so. So now we have an 8 and a 12. So now we can take 7 1s away. So 1, 2, 3, 4, 5, 6, 7. We're going to go ahead and just delete this. How many 1s do we have left? 1, 2, 3, 4, 5. So underneath that column, we wrote that 12 minus 7 is equal to 5. So now we need to move on to the 10 place value, and that is 8 minus 5, or 80 minus 50. But in the standard, it is 8 minus 5. So we are going to take 5 tens away. So 1, 2, 3, 4, 5. How many tens do we have left? 1, 2, 3. So we are going to write 3 on there. So we said that 8 minus 5 is 3. Do you notice how we don't have anything to take away from 3? So we can write a 0 there to also represent the 100 place value. So 3 minus 0 is 3. So on your computer or on your chip abacus and on your paper, you should have 3 100s, 3 10s, and 5 1s. And on your paper, it will look like this. And we just use the standard algorithm. Now, going through this problem, you probably have a couple of questions. Why do we stack the numbers the way we do on our paper with the place values instead of writing 300 minus 0 and 90 minus 50 and 2 minus 7? Well, in the standard algorithm, we are able to just put the number together on the top, and then we line up the place values on the bottom so the 1s are in line, so 2 minus 7, and then 9 minus 5, which is also 80 minus 50. This ensures that we get the correct measurement and the correct units and just the correct place values. And we start with the 1s because this allowed us to regroup. If we started with the 100s and worked our way that way, we couldn't regroup because we already found our answer. So it's easier when we use standard algorithm to start with the 1 place value and work your way up. So we are going to do one more problem together. We are going to do a bigger number for the bottom. So we are going to work on 403 minus 159. This is what it will look like on your paper. And I'm going to go ahead and get this set up on my computer. So on your chip abacus, you should have 4 100s and 3 1s. We didn't have anything in the 10 place value. And I'll remind you again with our problem. So 4 100s, no 10s, and 3 1s. We are going to work on subtracting 3 minus 9. If you remember from the previous problem, it's not enough. You can't do 3 minus 9. So we have to regroup to be able to do this. We would typically borrow or regroup from the 10s, but we don't have anything in the 10s. So we are going to move to the 100s. We are going to take 1 100 and exchange it for 10 10s. So now we have 3 100s, 10 10s, and 3 1s. We need to write this on our paper. So you are going to cross out the 4 and put a 3 above it because you exchanged 1 100 for 10 10s. So now we need to also write that on the 10s. We're going to place a 1 in front of it, like so. So now we could borrow from the 10s for the 1s. We're going to take 1 10, we're going to exchange it for 10 1s. So now we have 3 100s, 9 10s, and 13 1s. We need to write this on our paper. So we're going to cross the 10 out and write a 9 above it because we only have 9 tens left. And since we added 10 ones, we're going to write the 1 in front of the 3. And now you have 13. So since we regrouped and we borrowed from the 100s to the 10s, and we were able to take a 10 to turn it into 10 ones, we are now able to do 13 minus 9. So we're going to take 9 ones, 1, 2, 3, 4, 5, 6, 7, 8, 9. Gonna go ahead and delete this. How many ones do we have left? 1, 2, 3, 4. This is how you would write it. 13 minus 9 is 4. Now we are going to work on the tens, which we're going to do 9 minus 5. 1, 2, 3, 4, 5. How many tens do we have left? 1, 2, 3, 4. Another 4. So that is how we wrote it on our paper. And what is left is the 100s, and we're doing 3 minus 1. We are going to take 1 100 away, and that leaves us with 2 100s. So on your paper, you should have the answer 244. Now we were able to take this process and regroup while also not having to just subtract the place values because of the standard algorithm. This is a simple way to kind of push the place values to the side where we don't have to do 400 minus 100 and do those separate. Instead, we're doing it all in one problem, and this is an easier process for regrouping to be able to just subtract bigger numbers from the smaller numbers. And this is a great process to be able to make sure you have everything lined up, and helps with your organization skills as well. Before leaving this video, I would like to leave you with a problem for you to solve. So I would like you to solve 525 minus 379. There we go, 525 minus 379. I'm going to have you pause the video, and I'm going to solve this problem on my computer, and when we come back, we will go over the answer together. So on my screen, I have the answer for 525 minus 379. You can see that I am representing 146. On your paper, it should look something like that. So I first borrowed from the tens, and I turned the 2 into a 1, and then borrowed 10 ones, I put it in front of the 5. So it was 15 minus 9, and you should have gotten 6. And 1 minus 7 doesn't work, so I borrowed from the 100s, and crossed the 5 out and turned it into a 4. And since I borrowed 10 tens, I made 11, so 11 minus 7 is 4. And that left me with 4 minus 3, and that's 1. So I got 146.